Hey guys, let's go over the Integrated Math 3 Quiz 10, 311 to 312, basically radical functions and inverses. Question number 1, what does not pass the vertical line test? Remember the vertical line test, you actually just draw a bunch of vertical lines like I'm going to do on each graph. You can just put them at random places. And to review, when you have just one dot on the vertical line test, it passes. But if you're ever in a situation where there's more than one, then it fails. Okay, so those are the two options for the vertical line test, okay? All right, for example, on this one passes here because there's only 1 point. But here, it would fail because it's going through 2 points on that vertical line. So which one is not? This one looks like a good choice. Let's look at the other ones. I'm showing kind of green for passing or go. This works. Do you see how my vertical line is intersecting or passing through the graph? That one passes. So if this is a function, because it passes the vertical line test, we're again looking for ones that are not. So it's not going to be this one. Same thing here, passes, 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 then this one is a function. So this one is not what we're looking for. Same thing on this graph. I'll try to zoom in as much as possible. This one's the easy one. Okay, so a lot of students are probably going to think like, oh, it looks like a straight line down, but it's not. It's actually slightly curving, ever so slightly. So it's not a straight line down here. It's like just curving. So this one will also pass and pass. Come to me. There you go. You got to speak it. So that one is a function, so we're not looking for that one either. So our correct answer for number 1 is A. Number 2, the following graphs that for the following graphs that represents a function, so they're already telling you it's a function, determine whether its inverse will also be a function. Okay, so how do we do this graphically to text? Is you're going to do something called the HLT, which is the horizontal line test. And it's pretty much the same thing. If you have more than one dot, then it fails. And if you have just one dot, then it passes, and then you can take basically the inverse. That's what it does, okay? So let's take a look at these graphs. Again, you just do the same thing. You can just draw a horizontal line, a couple of places. Try to zoom in. This one. Alright, so those were super faint, but I think you get the idea. Let's go ahead and go through these. So then, if I go through here, this is 1 point, 1 point. It's probably going to intersect up here only at 1 point. So this one is, yes, you can take, too light, huh? You can take the, yes, you could take the horizontal line test. It's invertible, so you can take the inverse of that function. Let's take a look at this one right here. And if I just chose this one, that's 2 dots, so that would be a fail. So the answer for that one would be no. It fails the horizontal line test, so you can't take the inverse. It's not invertible. All right, let's take a look at this one over here. Okay, that's 2 dots. So that would, again would be a no. Same thing over here, just different parabolas. So it would pass up here, but it would fail on these 2 points right there. Okay, so that would be a no. Question number 3. Sketch a graph of the function f of x equals negative x plus 3 squared and its inverse. Use a solid line for the function and a dashed for its inverse. Okay, so we talked about before how we just need to graph first the parent. So the parent of this is a x squared. So if you put in 0, you get 0. You put in a 1, 1 squared is 1. Put in 2, 2 squared. So these are the reference points for a quadratic. Okay, that's the parent graph. Okay, and then you're going to do x plus 3 squared. If you look back at your transformations in 1.32, the trick I had was add to, let me write it out, add to x, go west or left. So you're actually going to shift each of the points left 3 units. So it's going to look like this. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So there is your new graph. And then the last one, this one had multiple. You had the negative in front. And remember that negative was the a value, which reflects it over the x-axis. So you're just going over. Stay. Count down 1, so 1. Count 2, 1, 2, then 1, 2, 1, 2. 1, 1. 1, 2, 1, 2. Okay, so this is my graph. Okay, so I'm going to darken this one because it said a solid graph. Just increase the thickness. Okay, now it says use a solid line for the function and a dash for its inverse. For the inverse, what color have we not used yet? Let's do green. Okay. For the inverse, we talked about how you're going to have to do a couple of things. We're going to rotate it 90 degrees counterclockwise, which is towards the left. So let's go ahead and do that first. So that means we would go in this direction. And it's pivoting about this point. So these would be your new points. So your graph's going to look something like this. Okay, that's the first one. And then the second one is that you have to rotate it about, reflect over the y-axis. So we're going to go over this line here. Okay, so here is -3, so we'll just put that at 3. And if you turn your head sideways, you can go like right 1, up 1, right 2, up 2, and do the same thing. Left 1, up 1, left 2, up 2. I know it's a little bit crazy, but let's see if we can put some good points in there. Let's put that in white because we haven't done white. So my inverse I'm going to use in the white color. And I forgot we were supposed to do dotted, but we can do magic. Magic. Okay, so the pink one is negative x plus 3 squared, and the dotted line is the inverse of that graph. And you guys were asked to actually just sketch that out. All right, question number 4. What is the domain of the function below? Remember, domain refers to the x-axis, and we determine this graphically by going from left to right. Okay, then it tells us use interval notation. So if you keep coming here, so look at the x number line. As I keep drawing these lines, there's nothing, there's nothing, there's nothing. Okay, there is something here on this graph. Look at the x-axis. The graph starts where? The graph is starting at 5. Okay, it is a closed circle, so you're going to use a bracket. And remember, this is not a order pair. Let's go back to our orange. And I'm just going to keep going, and then the last thing you touch on your graph is that arrow. Now this arrow is not pointing towards the y-axis, it's just the x number line. So this is negative infinity, this is going towards positive infinity. So the arrow says that the graph's going to keep continuing on. So this is the answer is going to be positive infinity, and I'm going to use a parentheses always with infinity. So that is the domain. What does that basically mean? It basically means what values can you pick for into our function here, and that's the input values. You can't pick negative numbers, but you can only pick 5 and 6, 7, and 100, all the way up to infinity. All right, let's look at number 5. 5 says the range. The range is referring to the y-axis, the y number line. And my little trick is going from bottom to the top. So start here, and then you're going to go up. Okay, so let's go ahead and draw a couple lines. There's nothing, there's nothing, there's nothing. Okay, the first thing you touch is this arrow. Now, again, we're referring to the y-axis, so look at the y number line. Let me highlight that for you. This is the y number line right there. So down here is negative numbers, and up here are positive numbers. So that arrow, although it's going towards the left, you're basically just saying that there are negative numbers, right? If I had to be dramatic, it's pretty much a graph. It doesn't look like that, but I'm just trying to tell you that there's way negative numbers way down there. So we just say negative infinity. And keep drawing some lines going up. Okay, and the last thing you're actually touching on the graph is another arrow. So that would be towards positive numbers, right? 5, 6, 7. Why is that the case? Because the graph's going to keep going up slightly for all of eternity. So the answer is negative infinity to positive infinity. Here's another way that you know that. This is an odd degree function. Does that make sense? And because they're going in opposite direction, the arrows, right? X squared would be even. But this is an odd, so odd's going in different directions. Do you guys remember the easiest one we've talked about earlier? Yeah, it's a linear. And look at those arrows. They're going in different directions, right? So the big idea here is that anytime that you have an odd degree, the domain or range will always be this, negative infinity to positive infinity. Okay, number 6. This one's a little bit off. I just want to make sure what you guys have. I think they wrote the graph. I want to make sure. Okay, yeah. So let me just cross it off. The answer, the question is -2 times x plus 4, and that 10 is there outside the radical sign. Okay, so the first thing we need to do is find the x-intercept. An x-intercept, you are making y equal to 0. So let's go ahead and do that. So I'm just going to copy this, copy, paste over here, paste, there we go. And we'll do that over here too. So we're going to have to do this problem twice. And while we're at it, let's just copy this one, move it over here. Okay. Okay, so we're making y equal to 0. So the y is over here. So and if you put in a 0 here, everything else is the same. And what we're going to do is we're just going to solve for this. We have to solve for x, okay? And one tip here I have for you is to use your PEMDAS. But remember, PEMDAS works this way, going down if you are simplifying, S-phi. But the one I'm using is here, we're solving. Okay? So this little box, I don't know, I haven't really found many textbooks or resources that have this. So I'm going to do addition and subtraction first, okay? So not inside the radical, that would be in the outside. So this would be a minus 10. This would be negative 10 equals negative 2 times x plus 4. And now I'm going to do multiplication and division. So the opposite, there's multiplication, so I'm going to divide both sides by a negative 2. This is going to give me a positive 5. Okay. And then, okay, so you can't touch what's in the inside until that radical sign's gone. So that's really there, the exponent. Remember, there's an invisible 2 here, so essentially what I'm doing is I need to square both of these. That is the opposite. So you will get 25 equals, okay, this 2 and the radical sign are gone, so you're just left with x plus 4. And then to solve here, you just subtract 4. So we get x equals 21. Okay? So when, to review that problem, when we made y 0, x was 21. So you can say for the x-intercept, x, y, so that would be 21, comma 0 is our x-intercept. Okay? Let's do the same thing on the other side. But this time we are finding the y-intercept, which means making x equals to 0. So I'm going to go ahead and do that. Let's make this one a little thicker. We're going to put in a 0 here. And then everything else is the same. Y equals negative 2 square root 0 plus 4 plus 10. Okay, we're doing the same thing now. Let's erase these so we can use these again. We are solving. So to solve, let's do addition and subtraction first. Now, you cannot do the 4 plus 10, but we can, sorry, let me try that again. Back up 20 seconds. So we are solving for y, but y is already on the left side, so all you have to do is simplify. Alright, so I can do 0 plus 4 inside, and that would give me y equals negative 2 square root of 4 plus 10. The square root of 4 is 2. Now pay attention. The relationship here is multiplication. And then I have plus 10. So essentially what I'm doing here is parentheses, exponents. Now I'm going to do multiplication and division. So y equals negative 4 plus 10, and then addition and subtraction. So y equals 6. So when x was equal to 0, y is 6. So my order pair is going to be 0, comma 6 as the y-intercept. And that's it. That's going over quiz number 10. We'll see you guys. Bye.